Alright, so let us start our lecture today. So in the previous class, we are trying to study Fourier transform, and the Fourier transform of a function f has the following form. So f has to be 2L periodic, right? So in the previous class, this is the formula that we have. So fx will be a0 plus the sum when n is going from 1 to infinity of an cosinus of n pi x over L plus bn sinus of n pi x over L. And we also have formula for a0 and a and bn. So a0 will be the integral from minus L to L. You take 1 over 2L mx dx. Right, so an will be 1 over L. The integral from minus L to L of fx cosinus of n pi x over L. Dx and bn will be computed similarly. N pi x over L. Alright, so how do you remember those formula? So a0 is what? A0 is the product of f with the function 1 here. And you divide by 2L, right? And what is an? So an will be the coefficient here. You compute an by multiplying f with this guy, right? So this guy will go here, all right? And to compute bn, what you do is you multiply the function f with the sinus. So bn is the coefficient of the sinus. In order to compute bn, you just have to take the inner product of f with this function. And of course, you have to remember that here you have L, but here you have 2L. So there's a difference between a0 and an, in which for a0 you have to remember that you are dividing by 2L, and for an and bn you are dividing by L, right? Right. So did we finish the triangle wave? No. All right. So now we are going to compute the example of the triangle wave. Which is a function of the form so you have minus 1 and you have 1, here you have 1. So the triangle wave is the triangle that you try to connect the point minus 1 and 1 and 1 and 1, right? So from minus 1 to 0, you have 1 plus x. And here you have 1 minus x. And I only care about the value of this function from minus 1, 1, because this is periodic with period 2, right? So f is 2 periodic. All right, so this is where we start. Now let us try to compute a0. So Fourier series of the triangle wave right? So we're gonna express this function in terms of all of those sinus and cosinus function. So a0 will be, we're gonna use the formula. So a0 will be 1 over 2L, L going from L to minus L to L, and I have fx dx, right? So this is the general formula. So in this case, what is the value for L?
It's just 1, so if you want
Yes, L is 1, right? L in this case is 1. So because this is 2 periodic, so normally the periodic will be 2L, and so in this case L is 1. So I'm gonna have 1 over 2, the integral from minus 1 to 1 of fx dx, right? Can you sign it? Right? So now what you have to do is to compute 1/2 of the integral from minus 1 to 1 of fx dx, right? So how do I compute this integral?
You split it,
Yes. From where to where?
-1 to 0, and then 0 to 1.
Yes. Can you sign at the back of the paper, please? So what you do now is you split this into the sum of the integral from 0 to 1 fx dx, right? And then you compute the integral from 0 to 1 of fx dx. All right? Right? So you split the integral from minus 1 to 1 into two integrals. The first one is from minus 1 to 0, and the second one is from 0 to 1. Now, what is the value of the function from minus 1 to 0? Yes?
1 plus x.
Mhm. Right. So from minus 1 to 0, you have 1 over 2, integral from minus 1 to 0, of 1 plus x dx. Right? And the other one will be 1/2 of what? Yes, can you sign the back? 1 minus x dx. All right? So what is the antiderivative of 1 plus x? X. Can you say in the back of the paper, please? So this one, you take the antiderivative, you have x plus x squared over 2, right? So don't forget the 1/2. And now you take the difference between minus 1 and 0. And what is the antiderivative of 1 minus x? Yes?
X minus x squared over 2.
Yes, can you say at the back of the paper, please? So this will give me 1/2 of x minus x squared over 2. You take the difference between 0 and 1. So the first one will give you 1/2 of minus 1 plus 1 minus 1 square over 2. Right? So the first one, I have 0, so this is going to be 0. So I'm going to have minus of minus 1 plus minus 1 square over 2. And the second one will give me 1/2 of 1 minus 1 square over 2. Right? So here I'm going to have minus 1 plus 1/2 is minus 1/2. So here I have 1/4. And here I have 1/2 plus 1/2 is 1/4. So in general I have 1/2. Right? It's clear? Questions? So I explain again. In this example, we're going to consider the triangle wave. The triangle wave is a function that takes value 1 plus x from minus 1 to 0, and 1 minus x from 0 to 1. This is a two-periodic function, so what I have to consider is just this interval, and I don't care about the others, because they are going to be repeated, right? Right, so I don't consider here. They are going to be repeated. Now, I'm going to use the Fourier formula. The Fourier formula says that, okay, if I have a 2L periodic function, I can write this function as the sum of A0 plus a linear combination of cosinus and sinus. The coefficient AN and BN can be computed this way, and A0 is computed this way. So I'm going to use this formula. I'm going to try to express this triangle wave on the Fourier basis. So A0 is computed by 1 over L, 2L of the integral from minus 1 to L of fx dx. In this case, L is 1. So I'm going to have to compute 1/2 of the integral from minus 1 to 1 of fx dx. Right? Now I'm going to split this into two integrals. The first one is from minus 1 to 0, and the second one is from 0 to 1. So from minus 1 to 0, I have this function 1 plus x. So I have the integral from minus 1 to 0 of 1 plus x dx, and the second one will give me the integral from 0 to 1 of 1 minus x. So I compute the first one. The antiderivative of 1 plus x is x plus x squared over 2, and the antiderivative of 1 minus x is x minus x squared over 2. I replace the two boundaries, and I find 1/2. right? So A0 is 1/2. Now let us compute the other AN and BN. Right, so I have AN will be 1/2L, integral from minus L to L of fx cosinus of n.
Isn't it 1/L?
But this, thank you. Can you sign at the back of the paper, please? Okay, so 2 pi x dx. All right. So AN will be 1/2 of the integral from minus L to L of fx cosinus n pi x of L dx, right? Now L is 1, so here I'm gonna have to compute the integral from minus 1 to 1 of fx cosinus of n pi x o, there's no over L dx, right? So what is the next step?
Separate it up to separate functions of f of x.
Yes, can you stand the back up, please? So you're gonna have to split this integral into 2 integrals, right? The first one is from minus 1 to 0. So you have mx cosinus of n pi x dx. And the second one will be from 0 to 1 of fx cosinus of n pi x dx. All right? So the first one, I'm going to replace it by 1 plus x. So here I have the integral from 0 to minus 1 to 0, 1 plus x cosinus of n pi x dx. And the second one will be the integral from 0 to 1 of 1 minus x cosinus of n pi x dx. Right? So to compute AN, again, you're going to use the formula. The formula is 1/L, integral from minus L to L. Fx cosinus n pi x over L. L is 1. And now, because the function is different in 2 intervals, minus 1 to 0 and 1 to 0, so you have to split this again into 2 intervals. The first one is the integral from minus 1 to 0 of 1 plus x cosinus n pi x dx. And the second one is the integral from 0 to 1 of 1 minus x cosinus n pi x dx. Right? Now let us try to compute the first interval. So the first interval, you have the integral from minus 1 to 0 of 1 plus x cosinus of n pi x dx. All right? So how do I compute this guy?
Factor it out, so you end up with the integral of cosine of n pi x plus x times cosine of n pi x.
Yes. Can you say it back the this? So now you're gonna have integral from minus 1 to 0 of cosinus of n pi x dx plus the integral from minus 1 to 0 of x cosinus of n pi x dx. Right, so what is the, so how can I compute the first integral?
Should you go change it to sine and then divide by remaining 5?
Yes, can you say it back this? So here I'm gonna have sinus of n pi x over n pi, and you take the difference from 0 to minus 1. Right, so this is 0. All right, this is going to be 0. So how can I
Can you do the U sum?
sorry?
Can you do the U sum? Like U substitution, U equals NX, or like B equals cosine X, and then take the derivative of.
Yes. Can you say the back of the paper, please? So for the second one, you're going to use integration by part. Yes?
How is that first term 0 again?
So the first term, what is the first term? The first term is sinus of n pi 0, right? Over n pi minus sinus of n pi minus 1 over n pi. Right, so sinus of 0 is 0. Sinus of n pi or minus n pi will be 0.
Okay, because it's
Yes. So for the formula that we need is that sinus of m pi x, m pi is always 0. For m to be 0, plus or minus 1, plus or minus 2, etc. Right, so this is the formula that we need. So sinus of 0 is 0, sinus of minus pi is 0, sinus of plus pi is 0, sinus of m pi is 0. So here, this is 0, and this is also 0. Now, the difficult part will be the second one. But for the second one, you're going to use integration by part, right? So what is integration by part? Integration by part says the following. You have the integral of u dv, right? So the integral is taken from a to b. You're going to have uv. You take the difference between a and b, and then you have integral from a to b of v du. Right? Yes? Yes. Thank you. Can you sign the back of the paper, please? So this is the integration by part. You have u dv. Integral will be uv minus v du. So in this case, you're going to do the same thing, right? So in this case, u is going to be x. Right? So this is u. This is going to be u, and dv will be this. All right? So dv, this is dv. So dv will be cosinus of n pi x dx. All right? So I'm going to use this integration by part. Here, u will be x, and dv will be cosinus n pi x dx. All right? So which means that v will be. Can you sign the back of the paper, please? Which means that v prime will be cosinus of n pi, and v will be the antiderivative of this guy, so it's going to be sinus of n pi x over n pi. All right? All right? So I'm going to use that formula, right? So a will be minus 1, b will be 0. U will be x, and dv will be cosinus of n pi x dx. Right? Now, dv is cosinus n pi x dx, which means that v prime will be cosinus n pi x. So v will be the antiderivative of this guy, so this is sinus n pi x divided by n pi. So I'm gonna have what? Have the interval from minus 1 to 0, x cosinus of n pi x dx will be, this is from minus 1 to 0, u dv, and this is uv. You take the difference between minus 1 and 0, plus you have integral from minus 1 to 0 of v du. Right? So x cosinus n pi x dx will be u dv. So this is going to be the difference between 0 and 1 of uv plus the interval from minus 1 to 0 v du. So I'm going to replace u and v, which are the function that I found here, to this interval. Right. So here I have x, I have sinus n pi x over n pi from minus 1 to 0. And on the other side, I have the interval from minus 1 to 0 of v, which is sinus of n pi x over n pi, and I have the x.
Is it minus or plus?
Yes, this is minus. Can you sign the back of the paper, please? So I always make the mistake. Okay, so I explain again. So here I have x cosinus n pi x dx, right? I'm going to use integration by part. I'm going to have u is x, and dv will be cosinus n pi x dx, right? So dv is cosinus n pi x dx, means that v prime is cosinus n pi x, right? Which means that v will be the antiderivative of this guy, which is sinus of n pi x of n pi. It's clear? Now, I'm gonna use the formula of both. So I have the interval from minus 1 to 0 of x cosinus of n pi x dx is u dv, right? But this u dv will give me uv minus 1 to 0 minus the interval from minus 1 to 0 v du. So the first one will give me this guy. So this is u and this is v. So this guy is 0 because of the formula over there, right? So sin s of 0 will be 0, sin s of minus n pi will be 0. So this is 0. So how can I compute the second one?
You'd have the same thing, just change the range on it from
Mhm.
0 to 1.
So I have,
Just like have 1 over n pi,
hmm?
and that's like a constant, and like take this sign would be like cosine over n pi x.
Right. Can you say at the back of the paper, please? So here I'm gonna have what? I'm gonna have cosine of n pi x, but here I'm gonna divide by n pi squared. So I have the minus here, it's fine. And I have the difference between minus 1 to 0. All right? Questions? Right? So here I'm gonna replace the antiderivative of sin n pi x, which is cosine n pi x, but I have to divide by n pi squared because here I have already n pi. So I have a minus here. So I replace this here, and this gives me cosine of 0 minus the cosine of minus n pi dividing by n pi squared. Right? So what is cosine of 0? 1. And what's the cosine of minus n pi?
1.
Minus 1?
Minus 1.
No?
It's
Who knows what is cosine of n pi?
zero.
No?
Negative 1 to the power of n.
Yes, can you say the back of the paper, please? So cosine of minus n pi and cosine of n pi will be minus 1 to the power n. Right, so this is 1 minus 1 to the power n, dividing by n pi squared. All right? So this is the, right, so this is another thing that you may remember. So cosine of n pi x will be minus 1 to the power n. Right, so this is 2 formulas that you have to remember. Right, so let me explain again from the beginning. Now I have to compute the first guy. This is just the first guy, and this is a lot of computation. So the first guy is 1 plus x cosine n pi x dx. So this is the integral that I have. So I'm gonna split this into the integral from minus 1 to 0 cosine n pi x dx, and the second one will be x cosine of n pi x dx. Right? The first one is easy. You just have to take the antiderivative of cosine n pi, which is sin n pi x dividing by n pi, and just take the difference between minus 1 to 0. So this gives me sin n pi 0 minus sin n pi minus 1, and they're both 0 because of the formula that I wrote here. Now I have to compute the second one. For the second one, this is going to be the integral from minus 1 to 0 of x cosine n pi x dx. So I'm going to choose u to be x and dv to be this guy, so that I can use the integration by part formula. So dv is cosine n pi x dx, which means that v prime is cosine n pi x and v is sin n pi x over n pi, right? Right, so this I write like minus 1 to 0 u dv. This is going to be uv, the difference between 0 and 1 minus the integral of v du from minus 1 to 0. So the first one is I replace u to be x and v to be sin n pi x over n pi. So I replace it here. The difference between minus 1 and 0 is 0. This is because of, again, sin of n pi is 0. Now, for the second one, I have to integrate from minus 1 to 1 of minus of sin n pi x over n pi. The antiderivative of this is cosine n pi x over n pi squared. And I take the difference between minus 1 and 0. So I get cosine of 0 minus cosine of minus n pi, and this is 1 minus 1 to the power n over n pi squared, right? This is the formula that we have here. It's clear? Right, so now let us try to compute the second one. So the first one, I know that this is going to be 1 minus 1 to power n over n pi squared, right? Right, so let us try to compute the second one. So the second one will be integral from 0 to 1 of 1 minus x cosinus of n pi x dx, right? So how can we compute this guy? Yes?
Since we know that cosine is even and the f of x is even from -1 to 1, then we know that that whole function is even, so you can just multiply what you have over there by 2.
This is a good observation, but this is not. Is it even? Yes. Right. Yes, this is an even function. Right. Can you say at the back, please? So you see that this is an even function. So when x is from 0 to 1, so you have 1 minus x cosinus of n pi x. So this is the function that I call fx. Right? So this is the function. Right? So let us consider x to be from 0 to 1 and fx to be 1 minus x cosinus n pi x. Right? So let us check if this is an even function. Right? So f of minus x will be from -1 to 0. Right? So f of minus x, f of x will be 1 minus x cosinus of n pi of minus x. Right? So I'm gonna write this like 1 plus minus x, sorry. Right? So I'm gonna write this like 1 plus minus x cosinus of n pi minus x, right? Which is exactly 1 plus x cosinus n pi minus x, cosinus n pi x, right? So this is f of minus x, right? It's clear, right? So which means that f is even. Hence, f is even, right? So the second one and the first one, they're the same. So this is going to be 1 minus 1 to power n over n pi x squared, right? So I recall you that if f is an even function, if f is even on -1 to 1, the integral from -1 or minus L to L, say, so the integral from minus L to L of fx dx will be 2 times of the integral from 0 to L of fx dx. But this is also the same with 2 times the integral from minus L to 0 of fx dx. Right? So in the previous theorem, what I wrote is that if f is even from minus L to L, then you have that integral from minus L to L of fx dx will be 2 times the integral from 0 to L of fx dx. But I did say that this is also 2 times of the integral from minus L to 0 fx dx. But this is provable, right? So the first, so to see the second identity, you're gonna see the following. So the first one means that you have the integral from 0 to L of fx dx plus the integral from 0 to L of fx dx is 2 times the integral from 0 to L of fx dx, and this means that integral from minus L to 0 of fx dx is also the integral from 0 to L of fx dx. Right? So in the previous class, I just wrote the first identity. But from the first identity, you see that the integral from minus L to L is also the integral from minus L to 0 plus the integral from 0 to L. Right? but this is 2 times the interval from 0 to L, so I subtract 1, so then the interval from minus L to 0 is also the interval from 0 to L, which means that you only need to compute either the first one or the second one, right? So which means that minus L to L of fx dx is 2 times the interval from minus L to 0 of fx dx. So let me explain this again. Yes?
Why did you change it to 1 plus negative x?
So this is fx, right? So this is 1 minus x cosinus n pi x, right?
Yes.
So 1 minus x is 1 plus minus x. Right? So,
Okay, yeah.
so 1 minus x is 1 plus of minus x,
Okay.
right?
Yeah.
1 plus minus x cosinus n pi minus x is f of minus x, because this is the f that we have. This is the f, right? Questions? Is clear? So let me explain again this whole thing. Right. So now we have to compute the interval from minus 1 to 1 of fx cosinus n pi x, right? So here I'm going to split it into 2 intervals. The first one is from minus 1 to 0, and the second one is from 0 to 1. So I call this fx, and I also call this fx, right? So this fx will be 1 plus x cosinus n pi x on the negative interval, and it's going to be 1 minus x cosinus n pi x when it is from 0 to 1, right? So this fx will be 1 plus x cosinus of n pi x when x is from minus 1 to 0, and s is going to be 1 minus x cosinus of n pi x is from 0 to 1, right? So I'm gonna have to compute the interval of this fx on 2 intervals. The first interval is from minus 1 to 0, and the second interval is from 0 to 1, right? So we know that on the first interval, this is 1 minus 1 to power n over n pi squared. So let us check if this is an even function, right? So you have fx is 1 minus x cosinus n pi x. X is from 0 to 1. Now 1 minus x is 1 plus of minus x, and cosinus n pi x is cosinus of n pi minus x. This is f of minus x because it's falling into this form, right? So which means that this is an even function. So if this is an even function, we have a theorem which says that you don't have, if you have to compute an interval from minus L to L of this even function, you only need to compute the interval from 0 to L, and you must multiply this by 2. So the reason behind this is that because if it is an even function, the interval from minus 1 to L will be the same with the interval from 0 to L, right? So which means that you can compute either one of them and you multiply by 2, right? So which means that here, finally, I'm gonna have an will be 2 times of 1 minus 1 to the n over n pi squared. It's clear? Questions? Yes?
So when we're computing AN and BN, is it advisable to always check if they're even?
Yes. The first thing you do is to check that this is even or odd. Then this reduces half of your computation. Right. Other questions? It's good. So let us try to compute BN. So this is B tab. So I think I'm gonna erase here. So I have Bn will be sinus of n pi x of n, right? So in this case, L is also 1. So I have minus 1 to 1 of fx sinus of n pi x over L. There's no over L, right? So this is n pi x dx. And this is integral from -1 to 0. So I'm gonna split the same. So I have sinus of n pi x dx plus the integral from 0 to 1 of 1 plus x 1 minus x sinus of n pi x dx. Alright? So to compute Bn, we're gonna use the same method. So you're gonna have to compute the integral from -L to L of fx sinus of n pi x over L, and you have to divide everything by L. So L is 1. I'm gonna replace this by the integral from -1 to 1 of fx sinus of n pi x dx, right? But fx is 1 plus x from -1 to 0, and 1 minus x from 0 to 1. Alright? So I'm gonna split it. I'm gonna split this integral into the sum of two integrals. Right? Right, so can you tell me what is the value of this integral?
0.
Why?
Because sign's off in this case around 0.
Yes, and
Because like 1 plus x, that would be even in this case, but since sign is odd, and you multiply in that case, it go to 0.
can you sign at the back of the paper, please? Yes. So in this case, we're gonna consider the following function, right? The function will be R. So the function will be fx will be 1 plus x sinus of n pi x. When x is from -1 to 0, and the other one will be 1 minus x sinus of n pi x when x is from 0 to 1. Alright? Right, so this function is an even function. This is an odd function because if you consider x from 0 to 1, you have f of x will be 1 minus x sinus of n pi x. So I'm gonna write 1 minus x as 1 plus or minus x, right? And here I'm gonna put a minus pi minus x. But when you put the sinus, you have to put a minus outside, right? And this is the form above, right? So this is f of minus x. And I have a minus. So f is R, which means that Bn will be 0. Alright? So I explain again. In this case, I split this f into two intervals from -1 to 0 and 0 to 1. On the first interval, I have 1 plus x sinus, and on the second interval, I have 1 minus x sinus. So I define a new function, which is 1 plus x sinus on the -1 to 0 interval, and I define the function to be 1 minus x sinus on the 0, 1 interval, right? So this function is odd because when x is from 0 to 1, fx is 1 minus x sinus n pi x. So I have 1 minus x is 1 plus minus x, and sinus of n pi x, I'm gonna put a minus here, but I have to put minus here. So this has the same form with the first one, right? Which means that this is minus of f of minus x. So f is an odd function, and the integral is 0. Right? So from this computation, we know that okay, Bn is 0. So what? So conclusion. An will be 1/2, right? A0 is 1/2. An is 2 over n pi squared. 1 minus 1 n, and Bn will be 0. All right? It's clear? Right. So again. All right, so I'm gonna put some remark on the the theorem that we have remarked. So if f is even, then you have what? You have the integral from 0 to L of fx dx is integral from minus L to 0 of fx dx, right? So if f is an even function, then the integral from 0 to L and the integral from minus L to 0, they're the same. So if fx is odd, so if I know the integral from 0 to L, what can I say about the other one?
It's equal to the negative.
Yes, I had the back to perfect. So I gonna know that this is going to be the negative of the other one. Right? Why? Because when you take it, because this one is the negative of the other one, which means that when you take the whole interval, it's gonna be 0, right? So then you have integral from minus L to L of fx dx is 0, right? So this means that you have the integral from 0 to fx dx plus the integral from minus L to 0 of fx dx, right? So when f is odd, the whole integral from minus L to L will be 0, which means that the sum of integral from 0 to L and the integral from minus L to 0 of f is going to be 0. And this means that one is minus of the other, right? It's clear? So these are the thing that we have to check first before computing anything. Questions? It's clear?
How do we? Never mind, I answered it for myself. Never mind.
Other questions? All right. So now we're gonna have another example, which is the following. So you have the parabolic wave. So I'm gonna erase over here. So I have the parabolic wave. So this is the example. Right. So let us try to do another computation to understand how to compute a Fourier series. Right, so let us consider the parabolic wave in which you have fx is x 1 minus x. When x is from 0 to 1, and x 1 plus x, when x is going from minus 1 to 0. Right? So this is a parabolic wave because it has the following form. So because when x is 0, this is going to be 0, and so it's going to be like when x is 0, the function is 0, so it's going to be like this. Right, so it's minus 1 to 1, not exactly like this. Right, so this is a parabolic wave because when x is 0, this function is 0. And when x is 1 or minus 1, this function is also 0. And this is a two-periodic function, which means that here you have repeating, and here you have repeating, right? Right, so let us try to compute the Fourier transform of this function. So this is the graph of fx. So we're gonna have A0 is questions. What is L in this case?
1.
1, right? So in this case, L is going to be 1 because f is 2 periodic function. So L should be 1, right? So L is basically this part. And 2L is the periods. So 2L will be the periods, which is double the distance between 0 and the limit on the right side. All right. So L in this case 1, and now I'm gonna have to compute A0, which is 1 over 2L. The integral from minus L to L of fx dx. All right. So in this case, I'm going to replace L to be 1. So I have 1/2 integral from minus 1 to 1 of fx dx. Right? So again, what I do is I split this into 2 integrals. The first one will be 1/2 of the integral from 0 to 1 of x, 1 minus x dx. And the second one will be 1/2 of the integral from minus 1 to 0 x, 1 plus x dx. All right? Right? Questions? It's clear? So let us try to compute this integral, right? So the first one will give me 1/2 of integral from 0 to 1 of x minus x squared dx. And the second one will be integral from minus 1 to 0 of x plus x squared dx, right? I just factor out. So what is the antiderivative of x minus x squared?
1 minus 2x.
What?
Is it 1 minus 2x?
1 minus 2x?
X
No.
squared over 2.
Oh,
X squared over 2 minus x cubed over 3.
Yes, so you just took the derivative. Yes, can you say at the back of the paper, please? So now I'm gonna have to take the antiderivative of this guy. This gives me x squared over 2 minus x cubed over 3. And you take the difference between 1 and 0. We have 1/2. Here I have 1/2. I have x squared over 2 minus x cubed over 3. And this is from minus 1 to 0. All right? So the first one will give me 1/2 of 1 over 2 minus 1 over 3 plus 1/2. So I have here a minus of 1 square over 2 minus 1 cubed over 3.
Shouldn't that, I was gonna say, shouldn't it be a plus in the second row?
So I have a minus outside, right? Because
Yeah.
they have 0. And here I replace minus 1 here and minus 1 here.
But shouldn't it be x squared over 2 plus x cubed over 3?
Yes. Can you sign the back of this? Yes, this is a very good remark. So what I have is 1/2, 1 over 6 plus 1/2. Here I have minus. Here I have minus, so 1/2 minus 1 over 3 is minus 1 over 6. And this is 0, right? Did I make a mistake? No. Yes?
No, I'm just looking at the thing wrong.
Mhm.
Oh, yeah, if we could just determine that this is an odd function, right?
This is
Save
an odd
ourselves
function.
a lot of
Yes.
trouble.
So this means that this is an odd function. But because the first one is simple, so let us try to compute it. And for the Bn and An, we're gonna check. So I have A0 is 1/2 of the integral from minus 1 to 1 of fx dx. So here I'm gonna have 1/2 of the interval from 0 to 1 of x 1 minus x dx plus 1/2 the interval from -1 to 0 x1 plus x dx, right? So x1 minus x is x minus x squared, x1 plus x is x plus x squared. The antiderivative of x minus x squared is x squared over 2 minus x cubed over 3, and the other one gives me x squared over 2 plus x cubed over 3. So I compute the first one, and this is 1/2, half minus 1 over 3, and the other one gives me 1/2 minus 1 square over 2 plus minus 1 cubed over 3. So the first one is 1/2 1 over 6, and the other one is 1/2 minus 1 over 6, and this is 0, right? So in the first one is always the easiest case. So let me write this down. A0 is going to be A0 is going to be 0, right? So now let us try to compute the second one. Right? So so now I'm gonna compute a Bn. Bn is An is going to be the integral from minus L to L of 1 over L of fx cosinus of n pi x over L dx. Right? So I'm gonna replace L to be 1, right? So this gives me the interval from -1 to 1 of fx cosinus of n pi x dx. All right? And I'm gonna split this into two intervals. So this gives me the interval from -1 to 0 of x 1 plus x cosinus of n pi x dx plus the interval from 0 to 1 of x 1 minus x cosinus of n pi x dx. Right? Right, so now we're going to check the function, right? So what can we say about the function?
It's odd.
Why is it odd?
Because f of x.
Yes.
And it's being multiplied by an even.
Right. Let me say at the back of this. So let us try to prove that this is odd or even. So I define fx to be x 1 plus x cosinus of n pi x, right? And this is x is from -1 to 0. All right. And the second one is fx will be x 1 minus x cosinus of n pi x when x is from 0 to 1. Right? So I'm gonna define two different values for x from -1 to 0 and 0 to 1, right? So here we have two functions combined to one. So now when x is from 0 to 1, I'm gonna write fx will be x 1 minus x cosinus of n pi x, right? So I'm gonna replace x by minus x. So this is minus x, right? So x is minus x. So x is minus x. 1 minus x will be 1 plus minus x, right? And cosinus of n pi x will be cosinus of n pi minus x. Right? So this is the form that we have here, except that we have a new minus. Right? So this is minus of f of minus x. It's clear? I explain it again. Now, I want to compute this an, which is, because L is 1, I'm going to replace everything by 1. So I have the interval from -1 to 1 of fx cosinus of n pi x dx, right? So I'm going to put I'm gonna have to split this interval into two. So the first one is from -1 to 0. From -1 to 0, I'm gonna put x, 1 plus x. And from 0 to 1, I'm gonna put x, 1 minus x, cosinus n pi x dx. I'm gonna consider one function which is a combination of the two functions that I have here. So the function will be 1 plus x cosinus n pi x when x is negative. And this function will be x, 1 minus x cosinus of n pi x when x is positive, right? Now when x is from 0 to 1, fx is x, 1 minus x cosinus n pi x, right? I'm gonna write x as minus of minus x, right? And 1 minus x is 1 plus minus x. And cosinus n pi x will be cosinus n pi minus x, because cosinus doesn't change size. If you change the thing inside the cosinus, right? But this is the form of f minus x, right? So because here you have minus x, right? So what is f minus x? F minus x will be, because in this case minus x is in this interval, right? So it is minus x, 1 plus minus x, cosinus of n pi minus x. Since x is now in -1 to 0, right? Because x is from 0 to 1. Minus x has to be from -1 to 0. Because minus x is from -1 to 0, I have to apply this formula, which is minus x, 1 plus minus x cosinus n pi minus x. And here I have an extra minus, so which means that here I have minus minus x. So f is an odd function, which means that this interval is 0. Right? So f is odd, which means that this an is 0. Right? Questions? So in this case, an is also 0. It's good. Now, let us try to compute dn. Any questions on even and odd functions? This is the key, right? So if you know that this is even and if it is not, you reduce half of the work. So now let us try to compute dn, right? So for dn, so what is bn? Bn will be 1 over L, the interval from minus L to L of fx, sinus of n pi x over L dx. Right? So I'm going to replace L to be 1. And this is going to be interval from -1 to 1 fx, sinus of n pi x dx. All right? So if you know that for an, it is an even function, for bn it should be odd function, and if for an is odd, then bn it should be even, right? So you have so if you compute an and you check that this is even, then the other term has to be odd, and if this is odd, the other term has to be even. So it has to be even, right? So to see this, I'm gonna have the interval from -1 to 0 of x, 1 plus x, sinus of n pi x dx. And this is from 0 to 1 of x, 1 minus x, sinus of n pi x dx. Right? So I'm going to follow the previous strategy. I'm going to define a new function, which is fx. It's 1 plus x sinus of n pi x dx when x is going from -1 to 0. And fx will be x 1 minus x sinus of n pi x there's no dx when x is from 0 to 1. We know that the previous one is odd, so this one has to be even. We don't check and we know that. Now we're going to prove it. So we know it is sure that fx is even since the other one is odd. Right? So the other one is odd, this one has to be even. Now let us check. So I'm gonna consider x from 0 to 1. Right? So fx will be x 1 minus x sinus of n pi x. So to check that this is even, how can I do it? Yes? Yes, so you're gonna try to f of minus x. So here I'm gonna replace what?
X of x equal minus x.
Yes. Can you stand in the back of the paper, please? So now x, I'm gonna see that x is minus of minus x, right? And 1 minus x is 1 plus of minus x. And sinus of n pi x is going to be?
Sin n pi minus x.
Yes. Can you say the sinus of n pi minus x? Right? So I replace x by minus of minus x. 1 minus x to be 1 plus minus x. Sinus of n pi x to be minus sinus n pi minus x. Right? Now this is the form. So I'm gonna cancel the minus here and the minus here. Right? So I cancel the minus, the 2 minus, so this is minus x plus 1 minus x, sinus of n pi minus x. Right? Now because x is in 0, 1, which means that minus x is from, no, x is from 0, 1, what is the value for minus x? What is the interval for minus x? Yes, can you say it back? So minus x will be from minus 1 to 0. So which means that I'm gonna use this formula. So f of minus x will be minus x 1 plus minus x sinus of n pi minus x. And this, so which means that this one is identical with this one. So this is an even function. All right. It's clear. Now I explain again. We're gonna compute Bn, right? So we know that when we compute An, we got an odd function. So An is 0. But this kind of thing is applicable to only An or Bn. So if An is 0, Bn will not be 0. And for Bn, to compute Bn, you will see an even function. So let us check it. So for Bn, you're going to have minus 1 to 1 integral of fx sinus n pi x dx. You're going to split this into 2 integrals. The first one is from minus 1 to 0, x 1 plus x sinus n pi x dx. And the second one is from 0 to 1, x 1 minus x sinus n pi x dx. All right? I'm going to define a new function, which is f, which is x 1 plus x sinus n pi x when x is negative, which is this value, and fx is x 1 minus x sinus n pi x when x is positive, which is this function, right? So we are sure that this is even because the other one is not odd. Now let us check. So if x is from 0 to 1, fx will be x 1 minus x sinus of n pi x. So x is minus x. 1 minus x is x, 1 plus minus x, and sinus of n pi x is minus sinus n pi minus x. So I can cancel the 2 minus. And I have minus x, 1 plus minus x sinus n pi minus x. Right? Because x is from 0 to 1, minus x is from minus 1 to 0. which means that you have to use this formula. So f of minus x will be minus x. I replace minus x here. I get minus x over there. I replace minus x here. I have 1 plus minus x. And over there, I'm going to get sinus of n pi minus x. But this and this, they're exactly the same, which means that fx and f minus x, they're equal. Right? So in other words, because they are equal, this interval and this interval, they're equal. We only need to compute one of them, right? So let us try to compute the second one. So this is going to be 2 times interval from 0 to 1 of x, 1 minus x, sinus of n pi x dx. All right? It's clear? Now, all right, so, yes. So, because we check and we know that this is equal to this one, we only need to compute one of them, which is either this one or either this one. So, I prefer to compute this one because it's positive, but you can still compute the minus one, or the minus 1 to 0, because it is still the same. So, finally, I have 2 times of this quantity, right? So, how can I compute this quantity?
Integration by parts.
Integration by part, okay? Right. So what is the u and what is the v in this case?
U is still the polynomial that x minus x squared in this case.
Right. Can you say at the back of the paper, please? So in this case, I'm gonna use u to be the polynomial. So u is always the polynomial, and v is always the cosinus and sinus function, right? And this is the dv. All right. So in this case, I'm gonna have u dv. So sinus of n pi x dx is dv, which means what is the value for v? Yes, can you say it back in the paper, please? So v will be minus of cosinus of n pi x over n pi. All right. So now I'm gonna use the formula. The interval from 0 to 1 of u dv will be uv. I evaluate at 0 and 1, and now I take a minus v du. Interval from 0 to 1. All right. Okay. All right. So I'm gonna use that formula for this u that I have here, which is x 1 minus x, and for the v that I found here. So u will be x 1 minus x minus cosinus of n pi x over n pi. Take the difference between 0 and 1. All right, and the other terms will be minus interval from 0 to 1 of v, which is minus cosinus of n pi x over n pi, and du will be d of x 1 minus x. Right? Yes?
Would it be easier to just factor through and like have it be x minus x squared times the sine, and then you end up with multiple integrals of just like x times
Yes.
sine?
That is also another way to do it, but you, again, you have to use integration by part twice for each term, right? So I do it this way. This is more complicated, but I have to do integration by part once. All right. So let us continue with this. So I have u, which is x 1 minus x, and v, which is minus cosinus n pi x over n pi. So v is computed because here I have sinus n pi x dx is dv, which means that v prime is sinus. So v should be the antiderivative of sinus, which is cosinus. So I have this formula. So I'm gonna replace this is u, and this is v, right? Of course, you can split it, and you do it twice. But if you do it this way, this is more complicated, but it's reduced the number of steps that you are doing. So here you have u and v. And here you have interval from 0 to 1 minus cosinus n pi x over n pi d of, this is dv, right? So for the first one, when x is 0, this is going to be 0. When x is 1, it is also 0. So we don't have to worry about that. So this is going to be 0. Right? Why? Because when you replace it, you're going to have 1 minus 1, right? And then you have minus cosinus of n pi over n pi, right? And the other one will be 0, 1 minus 0, minus cosinus of 0 over n pi, right? So this one will be 0 because you have 1 minus 1. And this one will also be 0 because you have 0, right? So this part will be 0, all right? Now for the second part, what is d of 1 minus, d of x, 1 minus x? Yes? Yes, sorry? Yes, can you say at the back of the paper, please? So the derivative of of x, 1 minus x, is the derivative of x minus x squared. All right? So this gives you 1 minus 2x. All right? So here I can cancel the 2 minus, have the interval from 0 to 1, 1 over n pi cosinus of n pi x, 1 minus 2x dx. All right? It's good. So here I have d of x, 1 minus x is 1 minus 2x dx. All right? So let me explain again. So I use the fact that this is even, which means that the two intervals are equal. I'm gonna need to compute either one of them, right? So the first, I'm gonna compute the interval from 0 to 1 because this is positive, so I prefer that. But you can still compute the first one. Now let us try to compute the second one. For the second one, I'm gonna use integration by part, right? So I have u. Normally in an integration by part, that you have polynomials and sinus and cosinus, you're gonna put all of the polynomial into one function and all of the sinus into one function, right? So in this case, I have x, 1 minus x. I'm gonna put it to be u, and I have sinus n pi x dx. So this is going to be dv. So sinus n pi x dx is dv, which means that v is the antiderivative of sinus n pi x. So this gives me minus cosinus n pi over n pi. All right? So I'm going to use this formula. So this gives me x, 1 minus x minus cosinus n pi x over n pi, the difference from 0 to 1. So I'm going to compute this difference, but this is 0 because this is 1 minus 1 minus cosinus n pi over n pi, minus 0, 1 minus 0 minus cosinus 0 over n pi. This is 0, and this is also 0. So this gives me 0. Right? So I don't have to worry about the first one. For the second one, I have minus of the interval from 0 to 1 minus cosinus n pi over n pi d of v. So dv will be x, 1 minus x, right? I can put 1 over n pi outside, and minus is going to be a plus. So x, 1 minus x prime will be x minus x squared prime, and this is 1 minus 2x, which means that d of x, 1 minus x, will be 1 minus 2x dx. So I replace it here, and I'm going to use integration by part again. Right? You can split, you can split, but you're going to have to do it 4 times. Here you do it integration by part 2 times, but if you split it, you do it 4 times. Right? Now, so let us try to compute the second one. So let us try to do 1 over n pi, interval from 0 to 1, of cosinus of n pi, 1 minus 2x dx. All right? So here, 1 minus cosinus n pi x this is going to be easy because you can take the antiderivative, right? So this is going to 1 over n pi, integral from 0 to 1, cosinus n pi, x dx minus 2 over n pi, integral from 0 to 1, of cosinus n pi x dx, right? So to compute this guy, I'm gonna split this into cosinus and cosinus times x, because cosinus is computable because you can just take the antiderivative, right? So what is the antiderivative of cosinus?
Sin n pi x.
Yes, it's going to be sinus, right? So this gives me sinus n pi x over n pi squared. And you take the difference between 0 and 1. This is going to be 0, right? So this is 0. Alright, so let us try to compute the second one. So I have minus 2n pi, integral from 0 to 1, of cosinus of n pi x dx. Right? So I explain again what I have just did. So I have cosinus n pi 1 minus 2 x dx. I split it into, the first one is cosinus n pi x, the second one is minus 2x. But I put all of constant outside to simplify the integral. So the first one, I can just take the antiderivative and this gives me 0. So let us try to compute the second one. Now for the second one, what is the u and what is the v?
U, so
Yes, the u is still the u, so let me put it here. So the u is always the polynomial and the v is always the cosinus to sinus, right? So u is x and v is going to be cosinus n pi x. So you have cosinus n pi x dx is going to be dv. So v will be sinus of n pi x over n pi, right? So what you do is you just take the antiderivative of cosinus and you get sinus, and don't forget to divide by the factor.
shouldn't it be negative sign? Because they're cosine.
No,
Oh, it's
no, cosine. The
Yeah.
antiderivative of cosine is sine, and the antiderivative of sine is minus cosinus, right? Now I'm gonna replace it here. So I'm gonna have minus 2n pi uv, which is x sinus of n pi x over n pi, and I evaluate at 0 and 1, right? This is again 0. So I have a plus because here I have a minus, so I have 2 over n pi. The integral from 0 to 1 of sinus of n pi x. So here I have a factor and I have dx. Alright? So let me explain again. So here I have u, here I have dv. So I apply the formula that I drew somewhere over there. So I have what? I have the integral from 0 to 1 of minus 2n pi u dv will be minus 2n pi uv evaluated at 0 and 1 plus 2n pi integral from 0 to 1 of v du. Alright? This is the formula. So you have minus 2 over n pi u dv is uv plus v du. So in this case, uv will be x sinus n pi x over n pi, right? And I evaluate at 0 and 1, but at both values, they're 0. For the second one, I have v du. So v will be sinus n pi, u will be dx. So this is fine. I remember to put this constant outside, so I have 2 over n pi squared, right? Alright, so again, now everything becomes simple because I only have to compute the antiderivative of cosinus, sinus which is cosinus n pi x, and a minus n pi, and I evaluate at 0 and 1, right? I take the antiderivative of this function, I get cosinus, but I remember to divide n by n pi, right? So we continue this on Tuesday. Have a nice weekend.